Okay, now onto the rules of ddx, which is differentiation. I'm gonna start with the notations, and then I'm going to go into the actual rules of ddx. I'm probably going to split this into a few videos because it's pretty long. Okay, so notations. So let's say I have y equals a function like this, okay? So if I want to find a tangent, then I just use this, ddx y. And then I will write this later. So ddx, this is like a verb. It is to find the tangent, to differentiate, okay? And then dy dx, this is like the noun. This is the slope, okay? I will probably just write something like this. This is to find the slope. Okay, so this is just notation. And then if I want to use something from here, then to find the dy dx but using a function, it will just be a dash here, apostrophe, a comma. Okay, it's called dash. And that is the basic notation. Am I missing anything? Okay. No, I will talk about that later. Okay. So there are a total of 21 rules, not including the quotient rule and the other chain rules and stuff. But you do have to remember all of these. Yes, that's what I'm trying to say. You do have to remember all of these, but after you look at the examples and do some questions, they should be easy to remember. And some of these, like these ones, the trigonometry ones, there are ways to remember these. These you will have to remember. These I would like you to prove. And then these you can remember or prove. Okay, so let's start with number 1. This one is equals to 0. And the reason why is because let's say I have curve, not curve, sorry, a line. So let's say my C is 1, right? So it's just a line, right? It's just a line. And if you know, right, the slope of a straight line like this, it would be 0. So in the end, ddx of a constant will be equals to 0. Change it back to black. Okay, now ddx of ax, and a is a constant, this will be a. The reason why is because, let's say I have a slope like this, right? And then this is y equals ax. Oh, this would actually not be that. I have to put this back to here so that the c is 0. Okay, so let's say this line is y equals ax, and then the slope of this would just be a, because you can see y equals mx plus c, and c is 0, and then m is the slope, and that is why it is just a. For this one, you would take down the index or the exponent of this, put it down, and then you would minus 1 from the exponent. The reason why, you have to go back to first principle, and if anyone wants to learn, then I will make a separate video, but you just have to remember that you would take down the index and then you minus 1 from it. Sine will become cosine x. Cosine will become negative sine x. Just bear with me, I will just write the other ones. Tangent will become secant square x. Secant will become secant x tangent x. Cosecant will become negative cosecant x cotangent x, and then this will become negative cosecant square x. Okay, so we went through these ones and now we get to these ones. Okay, so you will see a pattern here that when you differentiate something that starts with c, which is cosine, cosecant, and cotangent, they will end up with a negative sign. So that's the first thing you have to remember. And then the second thing is that sine will become cosine, cosine will become sine, and then just the positive and negative. And with the other ones, we have tangent, secant, and secant. Down here we write cotangent, cosecant, cosecant. So whenever you differentiate tangent, it will just end up with this. When you differentiate secant, you will get these two. Same thing with this. If you differentiate cotangent, you will end up with two cosecants. If you differentiate cosecant, you will end up with cotangent and cosecant. And that's how you remember these parts. So just try your best to remember them. It will take some time, which is why I'm doing this playlist first. And yeah, next video we will get to more.